Dear students, today we are going to discuss about Riemannian space, a beautiful part of the geometry, which is very relevant in the tensor calculus. So let us look what is the Riemannian space. Riemannian space are and what is the associated tensor, and that is the metric tensor. So in a rectangular Cartesian coordinate, the differential of arc length. We always discuss about this arcual length. So arcual, this is about the arc length ds. You know this between the coordinates x, y, z and the neighborhood coordinate x plus dx, y plus dy, and z plus dz is obtained from this metric. This ds square is equal to dx square plus dy square plus dz square, which comes from in the summation form. If you want to write, so summation of I is equal to 1 to 3, j is equal to 1 to 3, summation over gij dxi dx. J is the form of tensor. You may represent like this in the form of indices also, you can say. Okay, so by transforming to general curvilinear coordinate, such space is called the three-dimensional Euclidean space. So this geometry, this part of geometry we know at the PG level at least, and from the UG third year level, we know very well about such equation. Now, in on generalization with the coordinate x1, okay, this is the coordinate x1 x2 up to n tuples like xn. The differential of arc length xi and xi plus dxi, minded, arc length xi and xi plus dxi, where I varies from 1 to n, you will get ds square is equal to g. Just you vary the indices, the g11 dx1 2, and then g22 dx2 dx2 whole square, and then g33 dx3 whole square, and so on up to gnn dxn square, and so on. And plus you may rewrite the second set of equation g12, just you vary this, the g12 dx1 dx2. Okay, the g12 just to check here, this is dx1 and dx2 plus g13 dx1 dx3, and so on gkl dxk dxl, and the same may be written as summation over iota is equal to 1 to n, summation over j is equal to 1 to n, gij dxi dxj. This may be again rewritten as gij dxi dxj in short, or by using summation convention, you may write ds square. This ds square is nothing but gij, or nothing but dxi dxj. It means the coefficient of gij are the function of xi. It is very clear here, a function of xi, as this extension is due to the Riemannian. So the quadratic equation 1, as discussed in a separate PPT, is called Riemannian metric. This is called a Riemannian metric, and the arc length given by the previous equation 1 is called the Riemannian space. Okay, so now it is clear what is the difference between Euclidean space and Riemannian space. And the equation 1 from previous PPT may be rewritten as ds square is equal to dx1 square plus dx2 whole square, and so on up to dxn square. It is called a Euclidean metric, and such space is called Euclidean space of n dimension. Okay. Now, some points we have to remember. The distance ds in the n-dimensional space is scalar invariant. Minded. This is scalar invariant. Okay. And dxi into dxj is a tensor of order 2. Of course, you know this. This is a tensor of order 2. Gij must be component of covariant tensor of order 2. So it is also called the fundamental tensor. And the beauty of this tensor is this is always symmetric. Okay, so this is about the Riemannian space and Riemannian metric. This is the beautiful figure. Again, you always oftenly you go through the mathematics classes. So you just here it is once again summarized in the with the new look. This is this is 2D, a plain sheet of paper. Then this all the picture having the zero curvature. Okay, and this is positive curvature. We sometime we discuss about this positive curvature, and sometime this is such kind of the picture provide you the knowledge of negative curvature. Okay, so positive curvature, this also we deal separately in many part of mathematics, like in astronomy, spherical trigonometry, and then this is also some space calculation. We always do this. This is a negative curvature, but Riemann always passionate about deformation by Riemannian. Okay, but this is the deformation means crumpled paper. If you crump the paper, okay. So here it is very much clear. Riemann love to wrinkle the paper. So the 2D sheet become a 3D paper wall with inside several layers, dimensions. You may look, this is a sheet of paper, and then this is you can say the wrinkle paper. Okay, so wrinkle paper is the beautiful example of for this. And Remy, the Riemann book or and you look how and which type of figure you can frame by the wrinkling the paper and with in a different dimension. So here, of course, certain dimension. Whenever you do this, then that dimension is the hidden dimension. This, and we need to discuss this. Thank you very much. Thank you. Stay safe. Thank you.